train signal. You're watching a video about network media. In this video, we're going to talk about wired media. Now, we learned in the last video that media is what we used to connect computers to each other in a network. We also learned that there's both wired media and then also wireless media. Well, in this video, we're going to talk about wired media, or cabling. Now, we'll start off by looking at the three main types of cabling, which are twisted pair, coaxial, and fiber optic. After that, we'll talk about something called plenum grade cable, and we will answer the question, what the heck is the plenum? And I'll tell you what, that question has been asked just that way by many students over the years. So we will answer the question, what the heck is the plenum? Then we're going to go in and take a look at some of the common connectors that are used on these cables. We'll look at different wiring standards. We'll talk about LAN, which we learned in the last video is local area network, so LAN technology types. And then we'll see how to distribute our computers around the building, around the room, via wiring distribution. So first, let's take a look at our cabling, right? Our wired media. And the first one we want to take a look at is something called twisted pair. Now, twisted pair cable is divided into different categories. And you'll notice that up here, you'll see I have the word CAT. CAT is short for category. That's how we commonly refer to these cables. CAT 3, CAT 5, CAT 5E, and CAT 6. Let me get that line out of the way so you can read that. Those are the four most commonly used categories of twisted pair cable. But they're not the only categories. Now, CAT 3, you'll notice I have there, it says 10 Mbps. Now, that stands for megabits per second. And I will tell you that there's also an Mbps, which would stand for megabytes per second. But in that instance, the B would be capitalized. Okay, so when you see a lowercase b, that's megabits per second, or how many thousand bits per second. Now, category 3 goes a maximum of 10 megabits per second. That's the maximum throughput. So even that cable, I almost could have left off of this particular explanation, because in today's networks, 10 megabits just isn't going to cut it. I mean, we have high-speed internet connections, which would take us out of our local network. Even our internet connections will exceed 10 megabits per second these days. So realistically, the first grade of cable that you'll see out there today is Category 5. Category 5 can travel up to a maximum of 100 megabits per second, which is, well, we'll say, adequate for today's networks. You'll see a lot of networks today that still use not only Category 5 cable, but still use 100 megabit technology. But although you may see that in some networks, I would say that the majority of today's networks actually use Category 5E cable, and you'll see there that this Category 5E can go a maximum of 1,000 megabits per second, or what's commonly referred to as 1 gigabit per second, or a gigabit network would use Category 5E cabling. Now, besides Category 5E, you'll notice that we have here Category 6, which, well, it's listed the same. It's also used for gigabit networks. It's also for 1,000 megabits per second. The primary difference between 5E and 6 is 5E was designed, and I don't want to get too overly complicated here, but basically it uses the 100 megahertz range, whereas Category 6 uses the 200 megahertz range. And again, I don't want to get real overly technical and confuse you at this point, but I can tell you that Category 6 cable will be more commonly used going into the future, because although it's the same theoretical speed, you can realistically get higher actual speeds. I know that probably sounded confusing, but even though the maximum throughput is 1,000 megabits per second for both, it doesn't mean you're going to actually get 1,000, okay? Because there's interference and things like that that can have a lot of bearing on the actual throughput speed, and category 6 is not as susceptible to as much of the crosstalk and other types of interference that is out there. So realistically today, what's our number one type of cable that we're going to find out there? Category 5E, but we're going to quickly see that move into category 6 in the future on our gigabit networks. Now, the other thing I want to tell you about these categories before we go on is that the main difference as we go up through the categories, we'll say from 3 to 5 to 5E, the way we get the faster transmission is by twisting, right? We're called twisted pair cabling. By making more twists in the cables, by having them twisted more tightly, it has been found that data can travel faster. And just so you understand what we talk about when we say twisting, this right here is a picture of the inside, of what the inside of a twisted pair cable looks like. And you'll notice that right here, this is actually a pair of cables, and they are twisted around one another. And the reason they're twisted is because when you have two cables running in parallel with each other, well, then you tend to get what's called crosstalk, where you get signal bleed from one cable into the other, whereas when you twist them, that does not happen. Okay, so in a standard twisted pair cable, you'll see that there's 1, 2, 3, 4 pairs of cable for a total of 8 wires going through the cable. Don't worry about this item and this item. These are just extra fillers that go through the cable. They actually assist in the process of cutting into the cable and protecting the cable and terminating the cable, etc., etc. There are 8 wires in a twisted pair cable. Now, all of the different categories, so all twisted pair cabling, can travel up to 100 meters before suffering from something called attenuation. Attenuation is the deterioration of a signal over distance, and we could even say over distance and connections. The best way I like to describe it is if you were to stand, let's say, across a large room, a gymnasium, an auditorium from somebody else, right? You're on one side and you're on the other side. If you were to speak, let's say, in a normal voice, well, they may not hear you, right? Because the signal of your voice, the sound waves of your voice, are only going to travel so far before they start to deteriorate. They diminish. They diminish into silence. And so they don't hear you. Whereas if you're yelling, then they might hear you, because now you have given a stronger sound signal. And so that sound is going to travel a longer distance before suffering from that same attenuation. But even when you're yelling, your voice is only going to go so far, right? If you were, let's say, outside, you're not even in a room, you're outside. You yell as loud as you can, people are only going to be able to hear you a certain distance away. Well, that's attenuation. We have the same thing when sending an electrical signal over a copper wire, which is what twisted pair cable does use. It uses copper wire. Well, when that signal is sent out on the copper wire, twisted pair cabling will allow for up to 100 meters before you suffer from attenuation, meaning if a computer is more than 100 meters away from another computer, well, then it may never actually get the transmission because the signal will have deteriorated. Now, the next thing I want to talk to you about is the difference between something called unshielded twisted pair, or UTP, and shielded twisted pair, or STP. Unshielded twisted pair is susceptible to something called EMI, electromagnetic interference. If you were to run your cable through an area that has a high level of EMI, EMI is something that is given off by other electrical devices. If you were to run a cable, let's say along a generator, the generator is going to give off a lot of EMI. Something to be a little more common is, let's say you were running cables near fluorescent lighting. Fluorescent lights give off a lot of EMI. Well, that EMI is going to interfere with the signal on that cable. So when using unshielded twisted pair, you may actually have a problem if you are going to be in one of those areas. Now, this picture right here, the one that I circled before, this is an example of unshielded twisted pair. Whereas the picture below it, right down here, this is an example of something called shielded twisted pair. And it protects against EMI, and it's kind of hard to see, but if you look carefully, you will see that each of the twists have an extra layer of shielding around it. Okay, you can kind of see the difference right here in the cable. This is just bare wire exposed, and then right here is where you can see there's like a foil shield. And that foil shield, just so you know, is going to go all the way through the cable. This was just stripped off to show you that the wires are underneath these shields. Okay, so shielded twisted pair is used to protect against EMI. So if you have the need to run twisted pair cabling through an area that it has a high level of EMI, you're going to want to use shielded twisted pair. And the last little tidbit you need to know about twisted pair cabling is that it uses an RJ45 connector. And that's actually the picture we have up top here. This is what a typical twisted pair cable will look like on the end. It will have the RJ45 connector, and if that connector looks familiar to you, even if you haven't worked in computer networking, well, that might be because it looks just like a phone cable, right? Your telephone plugs into the wall using what's actually something called an RJ11 connector, which is a smaller version of the RJ45 connector. But we'll get into connectors in just a little bit. For right now, make a note, twisted pair cable uses an RJ45 connector. The next type of cable that I want to talk to you about is something called coaxial cable. Now, I will tell you before we even get into this that coaxial cable is pretty much a thing of the past. Okay, we don't see a whole lot of coaxial cable used in computer networking, and the reason why is, well, basically it was replaced by twisted pair, because twisted pair cabling, as you will see as we go through everything here, is, well, better. It's better, faster, easier to use, less expensive. So that's why coaxial cable really isn't used much anymore. But you need to know about this cable. Well, first of all, you should know a little bit of history. You should know how things were, not just how things are. But also, if you're planning on taking the Network Plus certification exam, you may get some questions about coaxial cable. Now, coaxial cable is made up of 4 layers. And in the drawing that I have right here, you'll see that we have a stripped down version of the coaxial cable. The first layer is the copper core. Okay, and that's this right here, this little wire. This is the center wire that the signal actually travels on. Okay, so that's the copper core where the actual electrical signal is sent. Outside of that, we have an inner insulator. Okay, so this is just a form of insulation that is used to separate the inner copper core with the shielding, or the wire mesh shielding. Okay, that's what we have right here, and this wire mesh shielding is used to help shield out crosstalk, EMI, things like that. Now, one of the things you may notice is that unlike twisted pair cabling, where we have the wires twisting around each other, we just have a single wire. And what that means is, if we were to take 2 coaxial cables and run them side by side, well, you'd probably get crosstalk going back and forth between the wires. Well, we avoid that, at least to some degree, with this wire mesh shielding. That's the purpose of that. And then the outer layer is just that. It's an outer insulator. It's It keeps you from actually touching the wire mesh shield. So that's how a coaxial cable is made up. It's made up of 4 separate layers. One for transmitting the data, one for shielding against crosstalk, and then pretty much an inner insulator to separate the copper core with the wire mesh, and then the outer insulator to, well, have an outside shield, right? Now, the most common form of coaxial cable that you would see if you were to see anything out there today would probably be something called thin net coaxial cable, or what's also known as RG58 specification of cable. I have a picture of a thin net cable right here. And some of the details about a thin net cable is it has a maximum throughput of 10 megabits per second. So it's slow, another reason why you don't see it used very often. It does have a maximum distance of 185 meters, so it can travel longer distances than twisted pair cable before suffering from attenuation. But, if you think about it, 100 meters, if you're not sure how far 100 meters is, and that's how far twisted pair cabling went, well, that's longer than a football field here in the United States, because, a meter being roughly a little over 3 feet, you're talking about a little over 300 feet. Matter of fact, I think the breakdown for 100 meters is 328 feet. So that's a long distance to have devices connected to each other. So there wasn't a whole lot of need for the 185 meters, which, puts us up at, well, just basically 2 football fields. Okay, so although it is nice over twisted pair cabling, it wasn't really needed. It uses something called a BNC connector, and that's this connector right here. And if you look closely at this picture, you'll notice that pretty much you have these slots where the other part of the connector, the reciprocal of this connector, would slide in, and then you'll notice this right here, this little curved slot. I'll actually clear all my drawing out of here so that you can see it. That little curved slot right there, well, that's what you do. You slide this over the receptacle, and then you twist it about a quarter turn around the little pegs around these slots. And there's another one on the other side of this cable you can't see. That's how a BNC connector works. And as I mentioned before, thin net has been, or I won't even say thin net, I will say coaxial cable as a whole has been primarily replaced by twisted pair cabling. Now, there's a brief mention when you look at the objectives for the Network Plus exam of RG59 and RG6 specifications, and I will tell you that these are typically not used in computer networking, and they are typically used for cable television. In other words, when you have a cable plugged in the back of your TV coming in from the cable company or from a satellite company, those cables are typically RG59 or RG6. Now, one real quick mention, I don't even have anything written on the screen here. I just want to mention, if we want to kind of go back through history, there was another form of coaxial cable called thick net. Right? That's where we get the name thin net, but we also have thick net, which was a thicker cable. It also went 10 megabits per second. It actually could travel up to 500 meters. So that was something that was typically used for your main trunk lines, as they were called, because it could travel great distances. And it used something called a transceiver connector, a 15-pin connector. So just kind of a quick side little FYI. If you're confused at this point, just forget the last 30 seconds of what I said. Just forget about that thick net. You don't need to know it. It's not used anymore. But just to give you a little history, there was something called thick net cabling out there, and that was another form of coaxial cable. Now, the last type of cable that I want to talk to you about here is something called fiber-optic cable. Now, first and foremost, the one main thing you should know about fiber, as opposed to twisted pair or coaxial, is that it uses light pulses instead of electricity to transmit the data. Now, this comes with A lot of benefits. First of all, it's more secure. See, when you send data over an electrical cable, there are devices that you can connect to that cable. And when I say connect, I mean to the outside of the cable. You don't even have to cut into the cable. You can actually do what's called tap in to the cable right on the outside and pick up that crosstalk that I keep talking about, some of that extra signal bleed that comes outside of that cable. So it's not very secure. Whereas with fiber optic cable with light, well, none of the light gets outside the cable. The other thing I can tell you is, well, speaking of cutting in, when it comes to electrical signals, if you were to cut in, so let's say strip away the outer insulation, so you give the bare exposed copper wire, well, you can connect another wire, and what happens just by nature is the signal will travel along all paths. So you can actually cut right into a cable and connect another cable and have all signals go to not only its intended destination, but an additional destination as well. So copper cabling is not very secure, whereas fiber is very secure. Another benefit is, well, it's not susceptible to EMI. Doesn't matter. You can have all the electromagnetic interference you want. It's not going to interfere with the light pulses. It's also very fast and can travel very long distances. So fiber optic cable, you might be thinking, wow, why would anybody use anything else, right? I mean, it's secure, there's no interference, it's very fast, it travels long distances. Why would you use anything else? Well, it does come with some drawbacks, and those drawbacks are that it is more expensive. So first of all, the cabling itself tends to be more expensive, but then also the installation of the cable itself. So hiring somebody to install it is more expensive, and the reason why is because, well, it's not as flexible. I mean, that not as flexible has two meanings. It has a literal meaning, it's not as flexible, meaning copper wire, you can do a lot with it. I mean, you don't really want to kink it all together, but you can bend it and twist it and do all kinds of stuff with it, and well, as long as the integrity of the copper is still intact, the signal's going to travel. Well, when it comes to light going through the fiber optic cable, that cable needs to be either straight, or certain cable can be arced at a certain pitch, at a certain degree, but you can't take a fiber optic cable and twist it into a knot. You just can't do it, or the light will never travel through. And actually, some of the older fiber cable, which you actually had glass, actually had a glass catting on the inside that the light traveled through, well, you would break that glass by bending that cable. Now, today's cables very often will have more of a plastic type material to send light through, so it has a little bit of flexibility to it, but not like copper has. Now, the other thing about not as flexible is, well, the actual, we could say, termination of the cable, the actual connecting, the plugging in, the actual configuring of how cables are going to run through things, well, that's not as flexible either. And so that's why it costs more to hire somebody to install fiber optic cabling for you. Now, here's what I'm going to tell you. The benefits are quickly beginning to outweigh the drawbacks. Okay? And the reason why is because we are in a day and age where security is a very big deal. Okay? So security very often outweighs everything else. We're also getting into a day and age where speed makes a big difference, right? We're getting to the point where we have large quantities of data that need to be transmitted, so we need to have great speeds. The other reason that fiber optic is really becoming more popular is those drawbacks. Well, they're not as much of a drawback. Fiber doesn't cost as much as it used to, and as I mentioned, it's becoming more and more flexible. So, that's the deal with fiber optic. It uses light pulses, it's more secure, doesn't get interference, very fast, long distances. It can be more expensive, but It's coming down in price dramatically. Not as flexible, but it's becoming more flexible. Now, beyond that, I'm not going to go into a whole lot of detail about all the different types of fiber optic cable. I will tell you that if you are going to become a cabling expert, well, then you're going to want to go ahead and get much more information about the specifics of fiber optic cabling. But for right now, just understand the basic concepts. Now, fiber optic uses 3 primary connectors. There are more, but there's 3 real common connectors out there. It's what's called the SC connector, the ST connector, and the LC connector. And the pictures I have over here, this is the SC, this is the ST, and this is the LC. So I have them in order from top to bottom. And the SC connector, which is also sometimes known as a square connector, and I wonder why it's called the square connector. Well, if you look here, it's kind of a square looking connector. The SC connector was one of the original connectors that was used out there. Sometimes, by the way, another way is it's known as the stick and click, because you kind of just shove it in and it clicks in. They have a very basic, just kind of push it in, pull it out kind of technology, and there were many advantages to that, so it was a very commonly used connector. Now, I will tell you that this connector is quickly being replaced, and I'm going to skip over this middle one, and I'm going to go down here to the LC connector, which you'll notice is also a somewhat square connector, but LC stands for little connector. Because it's smaller. You may not be able to tell from this picture, because these pictures may not be 100% proportionate to each other, but it's a much smaller connector, but you still kind of have that stick and click type connectivity. Now, the middle one we have here is the ST connector, and the ST connector is a stab and twist type connector. I don't know if you can see it. If you look real carefully here, you'll notice we have kind of this little arch here, and let me clear that out so you can see it. It kind of has that same type of idea that the BNC connector uses, in the sense that you push it in, and then once you have it in, you actually twist, believe it or not, instead of twisting the whole cable, you twist this outer barrel here. So you twist that outer barrel to lock it into place. So it's similar to the BNC, but in the BNC you kind of twist the whole cable, and it's kind of hard to describe without having a physical cable in your hand. But understand that the ST connector is used to kind of push it in or stab it and then twist it into place. So now that you know about the different types of cable, we need to talk about something called plenum grade cable, which begs the question, what the heck is the plenum? What's that word? Well, by definition, the plenum is an enclosed space used for airflow. So I have a little drawing here, and this is a typical office, right? Here we have our open office space here. And up at the top of the room, we have a drop ceiling, right? You'd find that in many offices. And I apologize, this may not have been drawn to proportion. But up above the drop ceiling, we have some ductwork here where we may have airflow coming in or out of the room. Well, the area within these ducts is what's known as the plenum. Now, usually the plenum is thought of as any space above this drop ceiling. So maybe this empty space up here, or down here we have a raised floor, right? We might have cabling running underneath the floor. You find that very often in server rooms. Number one, because you have a lot of cabling, and number two, sometimes we'll raise the floor because those server rooms are on the first floor of a building, or even the basement of a building, and you may get some water and you may get a flood, so you raise the room up to help protect some of your equipment against that. But anyway, very often the plenum is thought of as these hidden spaces. Well, actually, I will tell you that although technically they may not be the plenum, you may want to use plenum grade cable in those empty spaces. And the reason why is because if we go back to our drawing here, let me clear this out. Even though we may have designated space for airflow, what you may not realize is, well, maybe, over time or whatever, maybe there's a hole that has formed in the duct. I mean, that happens all the time. And then what ends up happening is air from this open space here leaks into that ductwork. Now, you might be thinking to yourself, wait a minute, Ed. So what? What does this all mean? Why do we care? Well, the reason we care is because your typical non-plenum grade cable uses polyvinyl chloride, or PVC, as the outer shielding on the cable. And PVC, if it were to catch on fire, melts and gives off toxic fumes. Aha! Now we start to understand. We don't want these toxic fumes to spread around and make people sick or possibly kill them. So they make a grade of cable called plenum grade, where the outer shielding on the cable is made of a material that if it were to get hot or catch on fire, it would disintegrate to a harmless powder. I can also tell you that standard cabling sometimes can help spread the fire. Sometimes a fire can actually spread along the cable, whereas again with plenum grade cable it disintegrates quickly into a powder and therefore helps prevent the spread of the fire. So, if you're confused, let me give you the real easy way to understand it. If you are going to have cable that is hidden in some enclosed space, either above the drop ceiling, below a raised floor, or I'll tell you what, sometimes you even end up, don't have a very straight line there. Here, make another shot at it here. Boom, there you go. You got channeling going along the wall. So maybe this is hidden behind a wall. Well, if you have cables in there, well, then you are going to want to use plenum grade cable. Now, another way that you can avoid this, because you might be thinking, well, plenum is more expensive, and yes, it is. The way you can avoid using plenum grade cable and still staying within fire code is you can run your cables through some form of conduit. Okay, that would be another way to make sure that you are safe if these cables were to run through a pipe. Alright, so now we've learned all about the different types of cable, right? We have our twisted pair, we have our coaxial, we have our fiber optic, and then we also have our plenum grade that we might have to worry about. Well, now that we know about the cables, what about the connectors? Alright, well, here are some of the common connectors that are used in today's networks. Well, first of all, we have the most common form out there, RJ45. RJ45 is used on twisted pair cabling. And when we were talking about twisted pair cabling, we talked about the RJ45. I said that it looked a lot like the typical telephone cable connector. Well, there it is. Right? There's your typical telephone cable with the RJ11 connector. And again, you'll notice it's very similar. Matter of fact, this extra protective rubber right here that you see on this little jacket is not always there. That's just this particular cable that I have a picture of. Okay, so the reality is that these two connectors look almost identical. Matter of fact, because these two pictures are not drawn to proportion, they look almost perfectly identical. The reality, though, is that the RJ11 does not have as many connections as the RJ45. See, the RJ45 is designed, and if you look real closely here, you'll see that there are 8 connectors there, whereas the RJ11 only has 6. And if you're real quick thinking, wait a minute, 6? I thought it was 4. Yes, it is true that telephone wire only uses 4 of the 6 connectors on the RJ11 connector. Okay, so RJ45 is what you will see in twisted pair cabling, but I wanted to show you RJ11 because that is kind of its little sister. Now here we have the BNC connector, right? We saw that with our thin net coaxial cabling. And then I mentioned RG59 or RG6, and this is probably a somewhat familiar looking cable, and that's because this is what you'll find on the back of your television, going out to the cable company or satellite, or maybe even up to a roof antenna, however you might be connected. But this up here is the type you would find in computer networking. And then here we have our 3 fiber optic connectors, which we were just looking at a few minutes ago, our SC, ST, and LC connectors. And again, I don't want you to worry about the actual specifications of these right now. Basically, I want you to know what they look like so that you could point them out if you were to either on a certification exam be asked a question, or if maybe somebody were to hand you a cable and say, "What is this?" And you can say, "Oh, that's fiber optic with an ST connector." Beyond that, unless you're going to be an actual fiber cabling specialist, that's all you really need to know. Now, there is one more type of connector I want to show you here. And it's right down here, and I've actually showed you the entire cable. This is an RS-232 serial cable. Now, serial cable is mentioned in the objectives for the Network Plus exam. So there's always a chance you might get a question about it. But typically, serial cables are not used anymore for any type of network communication other than maybe connecting into certain networking devices. You might still have the serial cable connection to plug in a monitor onto certain network devices, but even that has moved over into USB cables. So just on the chance that you get asked a question, an RS-232 connector, which are these connectors that you see here, and it's kind of hard to see, but that's what's called a female connector because it's solid and has holes in it. And then here we have the male version of the connector, which is where it goes around the outside, and there are 9 pins in there. The RS-232 connector is on the serial cable, and serial cable means just that. It means data travels in serial fashion, 1 bit at a time, one right after the other. There's not really anything else I want to go into there. Those cables are not used anymore, but I wanted you to see it in case you get a question on the test. Now let's take a look at some of the different wiring standards. Now here's a couple pictures that you've seen before, right? Here's the open version of a twisted pair cable, and then here's the closed version. Well, although you've seen those 2 pictures before, what we need to talk about is how do we get this to look like that? Okay, the way we terminate a twisted pair cable into the RJ45 jack, and we do so with these 8 wires being, and first of all, we open up the end, so we actually have 8 individual wires, not 4 twists, and stick them into the 8 different connectors. Well, we do that using the EIA-TIA standard of 568A or B. And those standards are what specify which colors go into which connectors. So if you were to take the RJ45 connector and you were to hold it flat, and then you take your 8 wires, which up here you'll see these are the green, and then although the other one looks white, it's actually green and white striped. And then we have orange and white stripe, and brown and white stripe, and blue and white striped. You'll see that those wires will be put into ports 1 through 8 in this order. The green and white goes into pin number 1, solid green goes into pin number 2, orange and white goes into 3, solid blue into 4, blue and white, orange, brown and white, brown. Okay? That's 568A. Now with 568B, you will see that it's almost the same except for the orange and the green have been inverted. In other words, we start off with orange and white and then go to solid orange, whereas before we had green and white and solid green. And then here for number 3, where we had orange and white before, and number 6 where we had solid orange, Now we have for number 3 green and white, and for number 6 solid green. What the heck does that mean, Ed? Let me explain what that means. Basically, those specific ports have to do with our send and receive, okay, or our transmit and receive. And so we've inverted those, and the reason we inverted them for the purposes of creating different types of cabling for different types of connections. And actually, let me move along into that. See, a regular, what's known as straight or straight through cable, has 568A wiring on both ends. And the reason why is because this is the type of cable you would use to go from a computer to one of many different network connection devices like hubs and switches and routers. And these are all kinds of devices we're going to get into later. But basically, if you're going into one of those devices, the port that you plug into is inverted within the device. So we use the same 568A termination on both ends. Whereas a crossover cable has 568A on one end and then 568B on the other. And the reason why is because this would be used to connect one computer to another computer. So as a for instance, if we go back here, let's say, and I don't want you to worry about exactly which wire does what when it comes to communication, but just as a for instance, let's say that the computer network card where this cable's plugged into is expecting to transmit data on pin number 3. Well, the problem you would have is if you had 568A on both ends, when you get to the other computer, well, this same wire is going to be plugged into pin number 3, and that computer is expecting to send on pin 3, not receive on pin 3. So that's where we would then invert it, and pin 3 would now be on the receiving end on a crossover cable, a different wire, so that it can send on one and receive on the other appropriately. So the crossover cable is 568A on one, 568B on the other, and basically what you're doing is you're taking the send and receive and you're inverting them. Now, a third type of cable is something called a rollover cable. Now, a rollover cable is going to have 568A on one end, and then it's going to have a complete reversal of the wires on the other. And what I mean by that is, let me go back to this drawing again. Let me get some of this stuff out of the way. This is how one side would be configured, but then what would happen is for the other side of the cable, you would actually have solid brown here on one, and the reason why is because solid brown is over here. You'd have brown and white over here, then solid orange, then white and blue striped, then solid blue, then orange and white striped, then solid green, and then finally green and white. In other words, you would completely twist the entire cable around. Now, this does not have a lot of typical uses. This is generally done for proprietary Cisco-based routers. Those routers have some specific needs for this type of rollover cable. So that's where you'll see it used. Now, the last type of cable that I want to talk about here is something called a loop-back cable. And the loop-back cable is one that is used to fool the computer into thinking that it's connected to another device. It's used typically for diagnostic purposes. In other words, you end up with wiring going in the cable, from the connector into the cable and then kind of back out to the same connector and right back into the computer. So basically the computer is going to send something out and it's going to go out wires that are going to be looped right back and plugged into the receive end of the computer so that it sends it to itself. You don't see this used too heavily. This again is used for diagnostic purposes only. So if you were trying to troubleshoot a specific network card, maybe the port, you want to see if the port's working, well, then you would go out and get a loopback cable or a loopback adapter so that you would plug in to make it believe it was connected to itself. All right, now the one last thing I want to tell you about these wiring standards before we move on is that straight cables and crossover cables, very often they are interchangeable with today's networking devices. And the reason why is because today's network devices have reached a level of sophistication to where they do what's called auto sense what type of cable is plugged in based upon what it's connected to on the other end. So very often you can take two computers, and if they have a newer network interface card in them, you can plug the two cables, take a straight through cable, and it'll realize, uh-oh, wait a minute, this isn't right, and then the network card will go ahead and reconfigure itself to go ahead and twist them around from a technological standpoint within the card on the chip. Or you could use a crossover cable, at which point it would say, oh, okay, we're on a crossover cable, so we'll work just the way we are. Same thing if you were plugging into hubs and switches and routers and things like that. So you need to know what these different types of cables are, but also understand with today's newer technology, you don't have to necessarily be that careful which one you're using. Now let's talk a little bit about LAN technology. LAN being local area network, right? So our localized networks within our office. And the most common form of network communication used in today's local networks is something called Ethernet. Now, there is another type of communication which very often is taught side by side with Ethernet, and it's something called token ring. But we're going to put token ring on the shelf for just a moment because we're quickly beginning to see that just go into non-existence. Okay, so Ethernet is primarily what we see out there. And Ethernet is something that is known as the 802.3 standard. Now, what the heck does that mean? Okay, so whoop-de-doo, it's a bunch of numbers and it's a standard. Well, let me tell you where that came from. If we wanted to get real technical here, I would tell you all about the IEEE, which is an organization made up of a bunch of geeks, which basically put together, they make a bunch of standards and stuff, and they created something called the 802 project model. And believe it or not, 802 is named after the year and month that it was created, back in February of 1980. But in that project model, there are a bunch of standards, and the one which is named 802.3 is the Ethernet standard. Or to be more technical, 802.3 is what defines something called CSMA CD access method. And that's what Ethernet uses. Ethernet uses this CSMA CD access method. Now, what the heck is that? Well, CSMACD stands for Carrier Sense Multiple Access with Collision Detection. All right. Not getting real far, are we? You're probably still saying, all right, I haven't understood a word you said. Well, here's how Ethernet works. Here's how CSMACD works. If we break apart what this all means, well, first of all, we have multiple access. Okay, the multiple access component of CSMACD means that we have a whole bunch of computers and they're all connected to the network and they all have access to this network simultaneously. Right? Multiple access to the network. The next part I want to talk to you about is the carrier sense part. And what that means is if I'm a computer and I have something I want to transmit to another computer, right? I need to transmit data out onto the cable. Well, I have the ability to kind of look out on the cable, almost like you're in a car looking to pull into the street. Look both ways and see if there's any cars coming. Well, we can sense whether the cable is currently being used, whether data is already being transmitted out on the cable. So that's what carrier sense is. Now, the collision detection aspect of CSMACD, well, as far as collision detection, it means just that. It means if we were to transmit data and that data were to collide, so let's say this computer and this computer both want to send at the same time, and even though they have the ability to sense whether the cable's being used, well, let's say they both simultaneously say, well, there's no one else transmitting, so I'm going to transmit. When this computer transmits, the data goes out on the cable and it travels in every direction along the cable. Simultaneously, this computer sends the data and it transmits in all directions along the cable. Well, eventually, the data is going to come to a center point and we are going to have a collision. And when that collision happens, data stops. Okay, the data did not get to its destination. Well, CSMACD has the ability to detect that a collision took place and that we have to retransmit. Okay, so the way CSMACD works is we have all these computers out on the network, right? All on the cable. And they all have the ability to check to see if anybody else is transmitting. If they see somebody else transmitting, then they wait. They wait for the cable to be free. They wait for the street to be clear. And then they go ahead and transmit their data. But in the event that two or more computers happen to transmit at the same time, well, then a collision happens. And when that collision happens, so in that instance where we had a couple of computers who both wanted to transmit, well, when they both send that data out at the same time, and then there's that collision, what happens is there's a random amount of time that each computer will wait before it attempts to transmit again. And the idea behind making it a random amount of time is that hopefully one of the computers will transmit first successfully, and then the other will transmit at a later time. And yes, it is possible that they could both theoretically wait the identical random amount of time, and then there, yes, might be another collision. And if there is, well, then we start the process all over again. I personally like to think of CSMACD as like a polite conversation. If you're having a polite conversation with another person and you have something to say in that conversation, what's the first thing you do? Well, you wait until the other person is done talking, right? So if we really want to analogize this, we're going to say multiple access in the sense that when you're talking to somebody, you both can talk to each other at the same, you both have access to speak whenever the heck you want, right? But you both have that carrier sense. You have the ability to listen to see if the other person's done talking. And it doesn't even have to be two people. Picture a room full of people, maybe in a boardroom, sitting around a table, right? You all have access to speak, but in a polite environment, you're going to listen to see if anybody else is speaking, and when there's silence, you then speak. But what can happen, even in a polite conversation? Let's go back to just two people. You talk, they talk. You talk, they talk. You talk, they talk. And then maybe there's enough of a pause, and you both had something to say. You both accidentally speak at the same time. And what happens? Neither one of you hear the other one, and you both stop talking, right? Transmission stops. Unless one of you is that much more assertive than the other, and you just speak over the other person. You continue talking. Typically, in a polite conversation, you both stop talking. There's kind of somewhat of a random amount of time. There is no designated rule. One of you might gesture to the other to go first, but one person speaks first and then the other. That's exactly how Ethernet works. Okay, so that's how CSMACD works. Now, the next thing we need to get into is a bunch of the different standard, as far as definitions of different types of cable and cable speeds and things like that. And the first one I want to talk to you about here is something called standard Ethernet. This is actually old, outdated stuff. I can tell you that 10 base T was our old category 3 twisted pair cabling is what it would be used on. But you will see these types of standards, and what we need to do is define what 10 base T means. Now the first thing is that 10 and base and T are three separate divisions of this standard. The 10 represents how fast, and the 10 equals 10 megabits per second. The base represents either what's called baseband or broadband, baseband being digital, broadband being analog, and base equals baseband. And then the T represents what type of cable, and as I mentioned a moment ago, T equals twisted pair cabling. And the reason I said that this would be similar to category 3 twisted pair cabling is because we have the maximum of 10 megabits, which is what category 3 cable uses, or what category 3 cable can handle. Now, some of the other technology types we have is something called fast Ethernet, which is broken down into 100 base TX and 100 base FX. Now, you'll notice that both are 100 megabits. That's why we call it fast Ethernet. And some people laugh at that today because 100 is not considered fast anymore. It's considered adequate. But back in the day, when we used to have 10 megabit as our standard Ethernet, 100 was fast. So both of these are 100 megabits. That's what makes it fast Ethernet. Both are baseband. So the only thing that's actually different is the TX and the FX. The TX represents twisted pair cable, and the FX represents fiber optic cable. So 100 base TX would mean that we were using twisted pair cabling over a digital connection that could travel up to 100 megabits per second. Whereas 100 base FX would mean that we're using fiber optic cable over a digital connection with a maximum of 100 megabits per second. Moving along, we have something called gigabit Ethernet, in which we have 1000 base T and 1000 base X. Again, both are 1000 megabits or 1 gigabit, thus the name gigabit Ethernet. Both are baseband, both are digital communication. And the difference here is that the T represents twisted pair cable and the X represents fiber optic cable. Moving on from there, we have 10 gigabit Ethernet. And you'll see that we have a bunch of them here. 10G base T, 10G base SR, LR, ER, SW, LW, and EW. They're all 10 gigabits per second. They are all baseband. Really, what the determination here is between all these different specifications is the type of cable. The T represents twisted pair cable. The SR, LR, and ER represent fiber optic cable. And now this is where we get into the confusing part. The SW, LW, and EW specify communications with sonic equipment. And sonic is something that we will talk about later when we talk about WAN communications. And that's why I say this is where it gets a little bit confusing because, well, we're talking about LAN technology types. But if we're going to connect into sonic WAN technology, then we might actually have 10 gigabit using SW, LW, or EW specifications. Now, I don't want to confuse you, and I don't want you to get confused, and I don't even want you to look into, right now anyway, the differences between SR, LR, and ER, or the differences between SW, LW, and EW. Basically what I've done here, and the reason I've listed these, matter of fact, on all of these past few screens, what I've listed are the exact specifications that are listed in the Network Plus Certification Objective Outline. These are the ones that you might see questions about. The reality is that to be a network specialist, you only have to have a basic understanding of these specifications. 10 base T, 100 base TX and FX, 1000 base T, 1000 base X, and then all these 10 Gs. But otherwise, don't worry about it beyond that. Alright, now the last thing that we need to go over in this video is wiring distribution. And I will tell you what, most of this is just coming right down to definitions. So this is definitely the not so fun stuff. Cross connects are cable which connect you to a backbone or provider. It's crossing over the connection from the actual computer and getting you into a backbone or a provider. When we say provider, it could be a WAN connectivity provider, internet provider, things like that. Typically, your cross connects are these patch cables that you find in a wiring closet connected to a patch panel. Well, what the heck is a wiring closet and a patch panel? Well, a wiring closet is just that. It's a box that holds a bunch of cabling and paneling. A patch panel, well, I'll tell you what, the best way to describe a patch panel, just give you a picture. This is what a patch panel looks like. And you'll notice that on the front we have, and it's kind of hard to see with the coloring here, but we have a bunch of ports right here and right here where we can plug in cables. And what you can't see, by the way, before we go into that, the white that you see up here above each of these ports, that's just a place to label the port, and that's always a really good idea when you're putting all this cabling coming in from all these different desks, and then they come in and they go to these different ports right here. You really want to have them labeled so that when you are trying to figure out what's connected to what out in your office, you don't have to run all sorts of different cable testing and the old-fashioned having somebody over somewhere else and you're plugging in and unplugging and is the light going on? Is the light going off? You don't want to worry about all that, so you should label it. But anyway, what you can't see, what's on the back side of the patch panel here, is a place where you will commonly find wires that are going off to the backbone or to the provider. And those are the cables that are typically referred to as your cross connects. Now beyond that, there's a couple other definitions here. We have MDF and IDF. MDF stands for main distribution frame, and it is just that. It's a frame that would hold main circuitry and power connectors and things like that. And IDF stands for intermediate distribution frame, which is a frame that you usually find not so much. The main distribution frame, I should say, you find in your wiring closets, whereas your intermediate distribution frame you find out in the office, where you might need to have an intermediary connector. Don't worry about them. They're just definitions. MDF, main distribution frame, IDF, intermediate distribution frame. From there, we have our 66 and 110 blocks, which are just that. They're wiring blocks used typically by the phone company. If you look at the picture, I know it's kind of a small picture here, but you have a whole bunch of phone cable, and they all get tied into these wiring blocks and get sent out then to the different phones around the office. You have some additional type of cable called 25 and 100 pair cable, and check it out. It's twisted pair cable, just like we saw with our standard, but now you have 25 pairs or 50 wires or 100 pairs or 200 wires in a cable. Again, I don't want you fretting over this. Just know what they basically are. If you actually need to use them, if you end up in a real world scenario where you need to use these, you're going to have a telecommunications expert who's going to be showing it all to you. If you're expected to be that telecommunications expert, well, then you're going to need to go out and take a serious cabling course. But to be network administrator, network specialist, you don't necessarily need to know more than being able to have a somewhat educated conversation with the telecommunications expert. Now we have demarc and demarc extension. Demarc, which is short for demarcation or demarcation point, is the point at which the telephone company's network ends and your wiring begins. Okay? And it's even on your house. You'll have the phone company, their wiring comes to a point on your house where if you were to look, you'll see there's a little box where you now begin your wiring, meaning the wiring that's in your house, or in the case of a company, the wiring within the company. A demarc extension is really nothing more than it's kind of like making an extension of the way the telephone company's wiring is in place, meaning there's a difference between the way your wiring is and the way their wiring is. And the demarc extension is when that exterior point where the telephone company's network ends, but maybe you're not distributing out to your network. Well, the demarc extension is this extra extension from the true demarc to where your distribution of your network begins. That would be probably the best way to put it. The distribution of your network begins. And the last thing we have here is something called the smart jack. Well, the smart jack is the actual termination of a T1 line coming from the phone company at your office. Okay, it's the actual jack that it's plugged into. And that is really all you need to know about wiring distribution, unless you're going to become a telecommunications expert. So, in this video, we talked about the different types of cabling, right? We talked about twisted pair cable, coaxial cable, and fiber optic cable. We learned what the plenum is and when you're supposed to use plenum grade cable. Basically, it's all about fire hazard, right? We don't want to have our cabling become an actual fire hazard, as in extending the fire. And we also don't want to create toxic fumes that might make someone sick or kill them. We saw some of the common connectors used in network cabling, and the most common connectors that you will see out there will be your RJ45 on your twisted pair cable, and then I would say the next most common would be your SC, your ST, and your LC fiber optic connectors. We learned some of the different wiring standards, 568A, 568B for our twisted pair cable. We learned about all the different LAN technology types, ranging from, first of all, the actual standards of Ethernet using CSMA-CD type communication, along with all the 10, 100, 1000, and 10G base, TX, FX, etc., etc. And we learned about our wiring distribution hardware. Whew! Well, I don't know about you, but that's enough for me to take in right now. So why don't we call it quits for this video? Go grab a little break, maybe grab a little caffeine, and I'll see you in the next video.